Okay, so yesterday we had seen like how to run Jenkins inside the Docker containers and what are the different commands we need, what are the volumes, why do we need it and all that. So today we are going to run Nexus server inside the containers, right? And also we are going to see few more commands like how to inspect containers, how to inspect a particular image, how to, let's say, inspect a particular volume, how to list the volumes, how to delete the volumes, so all that stuff. Okay. So let's start with running the Nexus in the Docker container. So let me go to the official image of Nexus, official Docker image. Okay, so this is the official page of Nexus Docker image, this Sonatype Nexus, and more or less the commands, the arguments are same. Okay, only the thing is in this location Nexus gets installed inside the Docker container. So if we want to mount our Nexus, so we can mount this location. Okay, so let's do this. I'll take that same command which we have executed for our Jenkins. So this is the command. We will just choose a different port, not 8083. Obviously we have to choose a different port, because if we want Jenkins as well as Nexus running in the containers, so our Jenkins port we have already forwarded to our Docker hosts 8083. So definitely we need to choose some different port to be exposed for our Nexus, right? So let me open command prompt and let's say Docker container ps-a. So this is exited our Jenkins container. So let's start this Docker container start Jenkins. So we can have both the just a minute, Jenkins new it is. Okay, so we can have our both the servers running parallelly, Jenkins running in one container, Nexus running in another container, right? So Docker container ps.
When I say Docker container ps-a, it is giving me status up 24 hours. So should I exit from that container?
No, that's fine. It means you already have your Jenkins running.
Okay.
So let's take this, and about volumes, I think I had mentioned that command also. Okay, if I have not mentioned, then let me mention the command. Okay, just a second. I think over here. Okay, if I have not mentioned the command for binding the mount, that's fine. I'll do that. Okay, so now what we will do is, yesterday in the Docker command itself, that is how we had executed the command. I'll show you that once. For the Jenkins, we had done something like this, -d and then -v, and then we had set Jenkins underscore volume colon and then the location which we want to mount. So our location was var/Jenkins underscore home. This is how we had executed a command, right? So I'll just copy it and put it in our document just for a reference. So in the Jenkins run only, I will put this and okay. that's fine. I'll just do this, and here I'll say above we are creating. I'll just highlight this portion. Named volume mount Jenkins underscore home. This will mount /var/Jenkins underscore home location from our Jenkins container on Docker host. Okay, so this is what we had done. Now what we will do is we can also create a volume separately as the way we create a container, the way we say create an image. So we can create a volume also as one of the object, and then we can attach it to our container while running. Okay, I'll show you that. So here we have a command to create a volume mount. See here. Just a second. Now here, Docker create volume, this one. So what I'll do is I'll create a volume first. Docker create volume, then the name of the volume, so I would say Nexus home, and colon, and then I have to provide which location from the container I want to mount to this named mount. Okay, so I want to mount this, and let's hit enter. Just a second. No, actually it has not recognized it as a volume command. Just a minute, I think there is a mistake here. Volume name. Okay, Docker create, just a second, CLS Docker create volume, then help. Let's understand. Docker create, just a minute. Yes, bind mount. Okay, actually this is for bind mounts. So let's learn this when we will learn about bind mounts. So for now, let's start the container the way we started our Jenkins container. When we will learn bind mounts, we will learn how to create a volume with the help of command. So for now, let's run the container like this, the way we did it with our Jenkins. So something like this. Only we need to change few things there in the command. Okay, so here I would say docker run -d name should be Nexus.
Pranay, can you also explain this command once again?
Yeah, sure. Nexus. Just a minute. Let me just complete the command, and then I'll explain. -p, so we have to provide the out port, okay, the port from the Docker host, and which we want to mount to a port inside the container, and the name of our image is this Sonatype /nexus3. Okay, so the command is, we are running a container, docker run -d, we want to run it in the detach mode. We do not want to attach our command prompt to the output of that container, right? So detach mode, -- name, this is the name of the container which would be created, -v, so we want to mount a volume, a named volume. Name of the volume is Nexus_volume. We can give any name, colon, which directory from the container you want to mount. So inside the container /opt/sonatype/nexus, this is the directory, the way we have for Jenkins /var/Jenkins_home. This is where all the files related to the Jenkins gets placed, right? So for Nexus, the location is /opt/sonatype/nexus3. This we want to mount so that we will not lose any data from this directory if at all we remove our container. -p, so we are publishing the port, so we are publishing the 8081 port. By default, Nexus server runs on this port 8081. We want to publish this and map it to our Docker hosts 8084. Okay, so this is the external port and this is the internal port which we want to publish or forward to. This port we want to forward to our 8084, and this is the name of the image, Nexus3, Sonatype/Nexus3. Now let's run this container.
Here 8081 is the
Yes.
run, right?
Sorry, can you come again?
8081 is the port where the Nexus runs, right?
Yeah, inside the container. So inside the container, Nexus runs on 8081, and we want to access our Nexus server on 8084 port of our Docker host. So that is what the port forwarding is. This is the port forwarding.
Got it. Thanks.
So now it is pulling the image. Once it will pull the image, it will run the container. By the time it pulls, let's access our Jenkins. So we are already running Jenkins, localhost. So this is the Jenkins. So our Jenkins is running. Correct. So our Nexus also got downloaded and container got started. Let's check. So see here, our Nexus container is also up since 10 seconds. Let's check the logs. Yeah, it is starting. Now we can access this on 8084. Yeah, it is not yet started, so we are not able to access it. But soon we would be able to access. So I'm just let it start. Yes, so it says that started, and here you can see the port 8081. It is the port internally. Nexus server has started on 8081. This, see here, now I am able to access my Nexus, which is inside the container. I do not have anything on my system. This is running inside. Okay, so let's, now it says that the password of our server is at this location, Nexus data admin.password. So now what we can do is, let's go inside the container. We have already seen how to go. Docker exec -it. -it stands for interactive. Name of the container, that is Nexus, and then sh. So we want to start a shell instance or shell session inside the container. So I'm inside it. Now we can go to this location, Nexus data. Maybe we can create a mount also if we want to, but sorry, cd/nexus -data ls-lrt, and this is the admin password. This is where we have got. So let's open this. Admin.password, and this is the password. Let's copy, and username is admin, and this is the password. I have got it from there. Yes, now I am logged in with the password they have given me. So we can change the password as we had done previously. Admin123, admin123. Next. So I would say disable anonymous access. Finish. Right. So now we are inside the container. Nexus running inside the container. So one container runs Jenkins, another container runs Nexus. Right. So now we can create our Docker repository. Now the way we had created Maven repository, right, to release our jar files. So similarly we can create our own Docker registry or Docker repository. So how to create? So you have to go to, yes, someone has raised the hand.
Yeah, hi Pramade. So for me, I'm trying to open this Nexus repository at port 8084, but somehow it is not loading for me. So like, what might be the issue? Should I wait?
Yeah. I'll let's wait for some time. If it doesn't start up, or you are not able to access, let me know. I'll just first show you how to create a Docker repository, and then how can we push our Docker image to this repository we have created, and after that I will ask you to share the screen if by that time you are not able to access.
Alright, yeah, thanks.
Okay, so you have to go to this repository. and create repository. Here we have to say Docker hosted, and we can give any name here. So I would say DevOps Docker repo, something like that. Yeah, doesn't matter. Let's skip this for now. Then let's scroll down. This is the same thing like deployment policy. We have already discussed about the deployment policy with respect to Maven. So those same concepts apply here. Cleanup policy and all the concepts are same. Let's create. Okay, now let's go to browse and Docker repo. Not here. Let's go here, repositories, and this is our URL for Docker repository. Okay, now what I need to do is, now what I want is I want to push any of my Docker image. We do not have our own Docker image as yet, but that's fine. What we will do is we will try to push this Docker image, Docker image ls. So we will try to push this Jenkins Docker image to our own repository. Okay, when we will create our own Docker image, a custom Docker image, once we will learn about Docker files and all, we will create our own Docker image and then we can push it to our repository. But for now, let's push this one. So before we can push, what we need to do is we need to say Docker login, and we have to log in to our Docker repository. So we have to provide this. Right, username admin, password admin 123. Just a minute, it says that localhost 8084 failed with status 404 not found. Okay. I am able to access it, so there is no issue. It looks like there is some, correct, there is some issue with the Docker login. Okay. Okay, 404, fine. Okay, I'll just check it. Maybe this is because our this Nexus repository is not HTTP secured. So what we need to do is let's go to Docker host, Docker desktop, and here we have settings, we have here Docker engine, and here we need to put one setting that will allow Docker to connect to a HTTP enabled Docker registry. Our Nexus is not HTTPS enabled, it's not secured, this one. So sometimes it gives the issue, not sometimes, even many of the times it gives the issue, but it doesn't give this error. Maybe this version of the Docker gives the 404 error, because it is trying to connect to a non-secure repository. So let me just get that. Connecting Docker to HTTP enabled Nexus. Oh, this is fine. I just want that. There is one setting I am not able to recall the name of it. So I'm just looking for that, which we need to put it into that daemon JSON. Just a second. Docker login. No, it still says that it is not able to found, meaning there is some issue with the HTTP and HTTPS, but there is some setting for that. Just a second. Non-secured, there is in the Docker daemon JSON we have to put non-secure registries, and there we have to put, just a minute, non-secured registries in Docker daemon. Say this, insecure registries. So we have to put this in our daemon JSON. So I'll just put comma, enter, insecure registries. Insecure because VR registry is not HTTPS enabled, so insecure. And I would say localhost 8084 and apply and restart. So it will restart the Docker. So we have to wait until it restarts, and then let's try. But if your registry is HTTPS enabled, then we don't need to do this. But if it is HTTP only and not HTTPS, then we have to. Okay. So now it is started. Now let's try logging in. Localhost 8084. Connection refused. Okay. Okay, I will check this because it should connect, because I am able to, just a minute, let me just check my Nexus server if it still runs. Okay, I think it has shut down. Okay, let me see that's the reason, maybe Docker container PS. My Nexus server got exited. Let me start the Docker container start. Maybe I had restarted the engine, right? So that's the reason both of these servers got stopped, because I restarted Docker. Okay, never mind. Let's start Nexus and Jenkins, both the containers. Yeah, so both the containers I have started. Logs. So this is how we need to debug also, right? So if we are not able to connect, so I was getting this error here. So that actually, that is from that I actually understood that okay, there is some issue with the server itself. So then I checked Docker container PS, so found that both the containers stopped. Reason being, I restarted, after this change I restarted the Docker engine. Yeah, let it start. Let's check the logs of our Jenkins. Yeah, Jenkins is up and running, so we can access Jenkins. Yes, Jenkins is up. Let's wait for Nexus. It will soon be up, and then let's try with Docker login. Yeah, Nexus is up. Let's access it from the browser first. Let's try. Yes, I am able to access. Now let's try with Docker login. No, it is still having some issue in connecting to the repository running inside. Okay, never mind. I'll just check the issue with this and we'll get back to you on this. Not a problem. I need to see like what is the problem. Otherwise, it should be able to connect, because from browser I am able to, from even curl I am able to curl it. Just I checked it. So if there is any issue, so there is no issue. I am able to access. I'll check what is the problem with the Docker login. No problem. Okay, now let's check how can we inspect a container. Now let's say I want to check, say for example, if my container, what all volumes it uses, then what is the image it uses, what ports it's exposed and all. Here I don't see any information about the volumes and all of, which are connected to the container. What is the IP address of my container? So I don't see that information here. I can only see what is the image it uses, then when it is created, since when it is up, what are the ports which are exposed. But if I want to know some more information about a container, then we can inspect. So I would say Docker container inspect, and I would say Nexus. So now this will show me all the information about the container. Let's check what all information it shows. Let me just take this inside a file so that I can show you inside the file instead of scrolling there on the command prompt. So I'm just redirecting. So I'm just running the same command, inspect. I'm just redirecting the output of this to a file nexus.txt. Docker container inspect Nexus. I don't have a D colon actually. Okay. Okay, I don't have even PD directory. Okay, let me just go and get some path which is already exist. I have a C colon only. Let me create a directory PD. Okay. And now inside this, yes, I have got the output redirected. So let's open and see what all things it shows. So it tells us that this particular thing first. What is the state of the container? It is running, right? Then the important ones, the image first of all, which Docker image it is using. This is the ID of the image it is using. Then if we see here binds, so currently this volume is attached to the container. Then let's scroll down, we can see the port bindings, that is port forwardings. So which port of the container 8081 is forwarded to which host port, that is Docker host port 8084. Then this auto remove is basically, now when we start a container, basically when we stop the container, if I stop this container now, Docker container stop and Nexus. So now if I stop this container would be stopped, but it will not be removed, right? We have to remove it on our own by doing some Docker container prune, right? Or we can even say Docker container RM and then Nexus. So now if you check Docker container ps -a, so the container is removed now. But the point is, once you stop the container, we have to remove it explicitly by either running Docker container RM or Docker container prune. But if you want a particular container to be removed as soon as you stop it, because if you are stopping it, let's say it means, say for example, you don't need it at all. Okay, if that is the case, that will not be the case always. Maybe you might want to stop the container for some time, maybe for some kind of a maintenance efforts and all. In that case, definitely you do not want the container to be removed. You just want to stop it for some time. You will do some kind of maintenance and you will start it. But if at all, in case of certain applications, as soon as you stop the container, you want it also to be removed. So what you can do is, and that you do not want to do explicitly, then what you can do is, in your docker run command, I'll show you. Docker run, where is our docker run command? Okay, not a problem, I have it here. Yes, so here when you run this, I'll sooner type Nexus volume and the location which you want to mount. Let me take it from here. Yes, 8084, 8081, name would be Nexus, and you will pass one more argument, that is --rm.
I think
Nexus 3.
Nexus 3, yeah. Nexus 3. Sonatype slash Nexus 3.
Okay. But they also have one image with the name Nexus, so that should also be fine. Okay, let me stop and make it Nexus.
So initially we created this Nexus container, and just now we have stopped it and pruned it. So now next time again, whenever we are running this Docker run command for Nexus, everything new will be created, right? All the previous traces will all be gone, right?
Yeah, of course. I mean, that container will go, just this Nexus volume would still be there. this would be there. I mean, to the previous container also we had attached this volume, right? What I want to say is here that when you don't specify this --rm, no, this, when you don't specify, like when you run this command without this, and if you stop the container will stop, but it will not be removed. Okay, but when you are now running this container with --rm, as soon as you stop the container would be removed as well. I'll show you. See, currently Docker container ps, my container is running. Now if I say Docker container stop Nexus, so it would be stopped as well as removed. That's what my point is.
So previously we have created a volume mount, right? Again to the same location, we are okay. We did not create a volume mount, I think so. We just tried to save it, right? Previously.
No, volume. This particular point which I am currently, making a point, it doesn't have anything to do with the volume. What I want to mention is about this. Do you see this --rm?
Yes.
Forget about volume for now. Let's remove this volume.
Yeah.
Just to concentrate on, let's say, what I am talking about. So when you don't specify --rm and when you run the container, forget about volume. Volume has got nothing to do with this rm and all. So now my container is running. Okay, my container is running. Okay, now if I stop the container, you can see the container is up, so it is running right now. So I am stopping it. So let's understand the difference. Docker container ps, the container is stopped. We can see -a, it is stopped, but it is not removed. Container is still there on your system. So if you want to remove it, you have to do it explicitly by Docker container either prune. So prune will remove all the stopped containers, or you can remove a particular container also which is stopped. So I'll say Docker container rm nexus. So here stopping and removing this is two-step process, right? So I have to stop, and after stop, if I want to remove, I have to remove it by running one more command, Docker container rm, name of the container, or Docker container prune. But what I'm saying is, if I want the container to be removed automatically as soon as I stop it, so I have to send one more --rm. So what this --rm will do, it will tell Docker that once this container will stop, remove it. We don't need to run one more step to remove it from our machine, is what my point. It has got nothing to do with the volumes.
Okay, got it. Yeah, instead of running one extra command, we are just
yes, exactly. That's what the point is. So now, if I now remove it, no, Docker container rm nexus, now it will be stopped as well as removed. Sorry, Docker container stop, I have to say. So it will stop as well as be removed. So see now, it is stopping as well as removing. See, now container, if you check Docker container ps-a, there is no Nexus container. It got stopped. After stopping it, removed it as well. Right, that is what --rm is, and that is what this auto remove is. So this auto remove is basically that. If you start the container with --rm, this auto remove would be true, and then it will understand, okay, I have to remove the container as soon as it is stopped. That is what my point is.
Okay, so I have one more query here, maybe not related to this remove, but my query is like yesterday, I just suddenly reminded this. So yesterday we were creating some volume mounts to just save some data which is present in Jenkins home or something like that, right? So whenever we are saving it, that is fine. I mean, even the container gets deleted, then the information will be present there. Let's say if I am again running a new Docker image in a container, and again if I am saving the information in that particular location in Jenkins post, can I do that? I mean, can I save the new Docker image running content in that in the same image as I stored previously?
Not image, same volume.
Sorry, in the same volume as I stored previously?
Yes.
Okay.
Why not?
So, like, will it be differentiated by anything so that we will know that, okay, which containers info is that?
No. You won't be, because the volume is basically, let's try to understand the use case of volume. Basically, the use case is, now if this particular container goes down, so whatever the jobs I have created, I want to preserve those. Okay. Now if the container has gone down, just to make this service available to my developers, so my developers are using this Jenkins running inside the container. Now for some reason my container got crashed. Okay, now simply what I need to do is I need to get that Jenkins up in some another container, just that data which my developers have created so far should not be lost. That is the use case. So there is no differentiation between, like, in that volume which container has created which data, which another container has created a different data. So that kind of differentiation you won't be able to do it. Even that is not required. The basic concept of the volume is to store the data on some persistent storage. So even if there is any issue with the container, you will not lose the container, because apart from the user data, we are not at all interested in any other things from that container, honestly speaking. Like whatever the Jenkins files it has for the installation and all, we are not at all interested in those things. Once you will run a new container, it will take all those things from the Docker image. What you are interested in is in your data, so that data would be present in that other container as well. And when you will create any new job, let's say in that Jenkins, another container, so that would still be stored in that same location where the mount is present. So if that container also got crashed and you start a third one, so still your data would be shared with that third container, and whatever it will create, it would be placed into that same location.
Okay, so all the information will be stored, and like we really can't segregate that, okay, which stopped container created which information on the mount. So it will be all available. We will not be able to distinguish
them. And even that is not even required. I mean, what we need is only, like, we want this Jenkins to be up and running always, so that my developers can use it. So we even don't care, like, what we care about is only, we should not lose the data if there is any container crash. So we will just take it up, and that is the problem, by the way, with the Dockers. If my Jenkins goes down, then my service will be stopped. Okay, and someone then will tell me, okay, this Jenkins is not working, can you please look into it, what has happened and all. Then the person needs to check, okay, whether the container is running or not running and all that. So service would be down until someone takes the corrective action. And that is where the Kubernetes comes into the picture. Even if your container goes down, Kubernetes will make sure to start the new one, and it will make sure that there won't be any downtime to your system. Right? That is the problem with the Dockers. Not problem, I would say, but that is why, people don't prefer to have the production systems deployed on the Dockers. They want some orchestration tool like Kubernetes, so it will take care of it. I'll show you when we will learn Kubernetes. Now I'll show you. I'll delete the container. I'll delete the, like here, if I stop the container, my service will be down. Docker container stop and Jenkins. So I have stopped the container. Now my service is down. Okay, my service is down. Until I go here, check what is the issue and get it up again, my service would be down until I do the corrective action. Right now I have started the container. Now it will take some time to start, but now the service is up again. That is the problem with the Dockers, that it is not self-healing. But Kubernetes is self-healing. Like if your pod goes down, it will start a new one and it will make sure that there won't be any downtime there, right? But when it comes to mounts, we don't really care who has created the data, which container has created the data, as long as I have my data with me, right, Rameshri?
Yeah, sure, Pranay. But I am just thinking of one point. Maybe this may not be a practical scenario case, but then I'm just asking this out of curiosity. So let's say from container one, if I have some jobs, let's say job 1, 2, 3, and somehow the container is crashed, but then all my information is stored in the volume mount, and I'm just running a new Docker image in a container, and then now I'm creating jobs 4, 5, let's say. But then and at this point of time, even 4, 5, 6 is getting stored in my volume mount, and somehow if container 2 is also crashed. But when I'm running a Docker image in container 3 in new container, and if I wanted to take the backup from the volume mount, but somehow if I think that whatever the information that was put in by container 1, that is job 1 and job 2, job 3, if I don't need this, or if I think that those are obsolete, then if I just wanted to use the information only from the which container 2 has stored, then in that case I will not be able to differentiate, right? So I will have to take all the jobs as the backup. Extra information is coming in for sure, but I will not be able to differentiate, and like whatever I need, I just can't take it as is. Like I just have to delete something or use only some specific things. So I was just thinking from that perspective.
No, but my point is, let's say you don't need the job 2. So, and you want to delete it. So how does it matter like which container has created it? It's simply that you don't need that job at all, right?
Yeah. So let's say in container 2, if I have this job 4, 5, and 6, and if I know that okay, whatever is there in container 2 I need, but what is there maybe I might have forgotten or something else. But in the latest
that's what my point is. Like, if you need a particular job, let's say 2, 3, 4, or you don't need it, there are only 2 cases. Either you need it or you don't need it. But my point is, how does it matter to you which container has created that job?
That's what, like, because I may not be able to recognize it with the help of the job names, but maybe with the help of the containers which created that job. If that is only the reference point, then I will not be, if I clearly remember the job names, then I will be able to use whatever I need and discard whatever I don't need. But with respect to one particular container, if some job is really running, but I'm not sure of the job details, but I just know that okay, so and so container has created so and so job, has so and so jobs. In that case, it will be difficult for me to take the information, right? So
obviously,
but that point,
obviously, but that is not some. I mean, let's take it in this way. Like, forget about the containers. Now you have installed the Jenkins on your system. Okay, you have taken the backup, like periodically backups you have been taking up for your data, Jenkins data jobs and all, and then you uninstall the current Jenkins and you install the new instance. Okay,
Yes.
now
Yes.
what happens, like does it tell you like which installation had created the job first, 1 2, and after you install it again you create few more jobs, so does it tell you like which installation has created those jobs for you? No, right? And even you don't care. What
Yeah, that's what.
matters
Generally, it
is,
doesn't tell, but
yeah,
like
but that's what,
because
like what matters to a user is if I need this particular job or not. I don't care like whether this particular job has been created by my previous installation or current installation or maybe future installation. It doesn't matter to me as a user, right?
yeah, definitely. I mean, this is not a problem if we really remember which container has created which job. But in case if we do not remember the job names, and only if we can think that so and so container has so and so job, I mean, so and so container jobs are the only things I need. In that case, we will not be able to clearly distinguish, right, from which.
Yeah, we won't be able to, but even that is not something which we also might be interested in remembering.
Okay.
Because yeah, as a user I only care about having my all the jobs which I have been which I have created so far. Okay, so I'm just interested in preserving that data. I don't care like which container has created it for me, because we don't create the Jenkins job for the containers. We have few release steps there, CI/CD pipelines, so that is something matters to me. It doesn't matter to me in order to take the decision whether I want it or not. So which container has created it for me, so that particular criteria doesn't matter when we take a decision whether we want a particular job or not, right? So it doesn't matter even.
All right. Okay. Thanks.
Now we can also inspect Docker volume inspect, and we can inspect the volumes also. See, now this volume I have inspected, so it tells us about different things about the volume. This is the name, the mount point and all that. It gives us the details about. I'll show you this location, don't worry, where it stores. It definitely stores on our system. I'll show this, but I'll show it to you once we will understand bind mounts, because bind mounts has got their own advantages. Okay, but we will talk about this. Right, so we can inspect volumes, we can even inspect images. I would say Docker inspect image, and you can inspect, let's say, this image. Sorry, just a minute. Docker inspect right, so you can see the different details about the image as well. Let me just C colon it is not taking this, just a minute. Okay, that's fine. let's not get into that. I just want to show you something here. Yes, so here we can see the details about like this one, CMD. So this is the starting point of the image, meaning when the container will start, which actually process it will run. Okay, this is the point. Which process, like in that image, which command, which process it will start. So it will start this nexus slash, this is what we used to do, nexus.exe space /run in order to run the server, right? So the image has this CMD. CMD is starting point or entry point of a particular image. So once you run the container, so this is the command it runs. So you can understand all those things. You can also understand what are the different environment variables. Sonatype dir, Nexus home. What is the Nexus home? Means what is the location where the Nexus is installed. You can see this. Where is the Nexus data kept? Nexus data meaning when you will create any repository, if you push any of the artifacts like jar file or Docker image and all that, so where they would be kept. So they would be kept at this location. So if you want to mount this location also, if you want to preserve your data the way we preserved all the things from our Jenkins. So if you want to preserve our Nexus data on our system using mounts, so we can mount this location from the container to a mount. Then these are their environment variables, by the way. These are being used by the Nexus, but we also can get the useful information about this, right? And this is important for us to know. We don't need to know any other things from this. So what is important is what is the starting command and what are the different environment variables if we wish to know about them, right? So these are the information. So we can inspect basically different aspects of container, of image, also of a volume.